another question, which I think is a really something I don't know a lot about. Um, the quantum kind of effect, I guess, like because you mentioned quantum computing, I think maybe, or we might have touched
Yeah.
on that. But like, what does it mean when you're talking about the quantum world and the quantum effects? And is that something that you guys look at a fair bit in your test for stuff? Uh,
Yeah. Okay. That's tough. Yeah. I mean, our whole theories are based on quantum mechanics. Like
yeah,
the standard model of particle physics is quantum mechanical. So it uses quantum mechanics on which it's based.
yeah,
Um, what, I mean, that's because it is like it is the accepted theory for the way that things work on that level, and it has a lot of evidence, I guess, to back it up. But I think I don't, when it comes to things like using quantum technology, like quantum computing, I don't fully understand. I have to admit, how that works.
yeah.
I would need to look up. I would need to look that up, to be honest.
So
And
I saw something recently, because I was trying to familiarize myself um with complex numbers, because I was just doing some kind of thing. So it's when I watched some video, it was talking about um complex numbers, um which is like the real and imaginary, isn't it? Is that what I'm talking about? Or is that imaginary numbers? Complex numbers is got a real part and an imaginary part.
yeah, yeah, yeah,
Yeah. Okay, cool. So I'm talking about the right thing, and I think that's used a lot for quantum mechanics. No, that's what the guy said in the video, anyway. And something to do with like basically what he was saying in the video was like, especially with things like electronics, we only often care about the real part.
yeah,
Um, but apparently the complex numbers maths makes some of solving some of those problems easier. So you can actually
yeah,
solve them without it, but it makes it makes solving those problems a lot easier. And then the second thing that reminded me of was with the antimatter thing, because
yeah,
obviously there was the real and the complex, the imaginary part, right? And the imaginary part was like the antimatter thing, I think. Um, and so I just wonder, basically, what does that mean to you in terms of when you're looking at data? Is it like, do you rule out the imaginary part, or what's your focus when it comes to the actual maths behind it, to make it quantum, right? Is there like some real and imaginary part to all of these answers, or is it nothing to do with that? Um,
No, I mean, I think there are obviously complex uh, parts of the theory. It's and quantum. What we use is like quantum mechanics basically describes things as having probabilities. To be to do things a certain way. For particles decaying, it's a probability. It's
okay,
not like a fixed. We know that. That's why in our whole kind of field is like looking for things that happen that are rare, because the probability that they happen is low compared to the probability of other things. But you still don't know exactly when you're going to get the decay that you want. It's just a likelihood of it happening. And that kind of physics is really what quantum mechanics is all about. And that's why, we kind of accept that you also need an element of luck, to do some of these things. You want to be able to see the decays. Just because it should happen 1 in 10 times doesn't mean if you roll the dice 10 times you'll get it once.
so how do you make sense of that idea, that because for me, that obviously in the natural world that we kind of observe, things aren't just like there. Sometimes they're not there. Sometimes, like
Yeah.
the chair's here, the wall's there, pretty much all of the time, from my observation. And so, how do you reconcile that idea? Do you feel like it's an accurate way, or do you feel like, or is there something, for example, that maybe we just don't know, and so what we observe is like probability, but actually there is an absolute answer? So I'm just basically saying, how how sure are we that
Yeah.
things are kind of probabilistic and not um, certain, but we just have no further kind of understanding? Because I noticed there's like like the uncertainty principle or something like
Yeah.
that. There's a few things to do with observation and such. So I'm just asking kind of the deeper questions on that, I guess.
Yeah. That's a good question. So, I mean, obviously you can say that, people can say, we just don't know enough yet to understand the fuller theory. But everything that we've kind of tested so far seems to agree with what quantum mechanics tells us. And I think, one of the things is that, for me, it's not too hard to imagine that that is what the world is like on some level, because the very basis that we think it shouldn't be on that level is a human construct
Of course, yeah.
based on something. So, everything that we think and feel is just is a kind of consequence of us as a species adopting these principles, of right and wrong and up and down, you know, um, like, so what's to say that, when we came up with the theories that physics has to be based on things always happening at a set, it has to be here or there. It can't be in both, or it can't be a probability of it being in both. That was based on the limit of the knowledge we had at the time. And now we've evolved beyond that. And so if the science is telling us that, and it's verified by experiment, then I don't have a reason to doubt it. Just like I wouldn't have had a reason to doubt it before, when the evidence was there to support Newtonian mechanics. It was when we kind of got more data and more sophisticated theories that, that things became a bit clearer to us that Newtonian mechanics didn't explain everything. So until, I guess, we get to a position where quantum mechanics doesn't explain things, then maybe we have to go further. But I don't, that's just the name of the game in terms of furthering our understanding. So I don't really have an issue with it not being, fixed, like, set in stone exactly what's going to happen.
Cool.